Hello, my name is JaeIn Won from Kawan Science High School in South Korea. Even when the same material is used as a CO2 absorbent, some forms capture more CO2 while others can be reused for longer. This difference may come not only from the material itself, but also from the form in which it is made. In this study, I introduced MWCNT into a Chitosan-Zeolite composite and fabricated it in three forms: powder, beads, and filter, then compared how the fabrication methods affected CO2 absorption performance and regeneration stability. My presentation has four parts: introduction, methods, results, and conclusion. I will first explain the background and purpose, then the methods, followed by the results and conclusion. Let me begin with the introduction. As the climate crisis intensifies, direct CO2 capture is becoming increasingly important. Although conventional amine absorption is effective, it still has drawbacks such as high cost, corrosion, and high energy demand. For this reason, reusable solid absorbents have attracted attention as a promising alternative. To improve the composite performance, I introduced multi-walled carbon nanotubes. Because MWCNT have a high surface area and strong mechanical properties, they were expected to improve absorption sites and structural stability. Chitosan contains primary amine groups, so it can absorb CO2 through chemical interaction. Zeolite, in contrast, has a porous structure and a large surface area, which makes it suitable for physical absorption. By combining these two materials, a complementary absorption system can be built. Adding MWCNTs may further increase surface area and reinforce the structure. Previous studies mainly focused on only one form, such as powder or beads. However, the form of material can strongly affect surface exposure, gas diffusion, and stability during repeated cycles. Therefore, the purpose of this study was to compare powder, bead, and filter forms of the same Chitosan-Zeolite MWCNT composite in terms of CO2 absorption and regeneration stability. Next, I will explain the methods. The powder type composite was prepared according to the schematic procedure shown here, and the bead type and filter type were prepared according to the diagram shown here too. The CO2 absorption experiment was carried out in a glove box. After adjusting the CO2 concentration, the change in concentration was measured in real time. Now I will move on to the results. The powder form showed the highest absorption capacity, the bead form the lowest, and the filter form intermediate performance. These differences are likely due to structural differences, especially surface exposure and accessibility of absorption sites. In all forms, the composites containing MWCNT showed higher absorption capacity than the composite without MWCNT. This suggests that the MWCNT had a consistent positive effect on composite performance. The pseudo-second order model showed the best fit for all samples. This suggests that CO2 absorption involved not only physical absorption, but also chemical interaction within chitosan. The filter form showed a relatively short equilibrium time, suggesting faster gas diffusion, so the powder form was best for maximum absorption, while the filter form showed an advantage in absorption rate. During repeated absorption-desorption cycles, the MWCNT containing composites showed better performance retention. The Keto-Zeo MWCNT bead showed the highest regeneration performance, followed by the Keto-Zeo MWCNT powder. This shows that the best material is not always the one with the highest initial absorption. Although the bead form had a lower absorption capacity than the powder form, it was better for repeated use. The same images show that chitosan and MWCNT were attached relatively uniformly to the zeolite surface. This indicates that the composite was successfully formed. Now I will move to the conclusion. This study leads to three main conclusions. First, the fabrication form significantly affected CO2 absorption performance. Second, adding MWCNT improves both absorption performance and regeneration behavior. Third, when practical use is considered, the bead-type composites containing MWCNT appears to be the most favorable design. Although the powder form showed the highest absorption capacity, the MWCNT bead showed the best balance between absorption performance and regeneration stability. For this reason, it is the most promising candidate for a reusable, environmental-friendly solid CO2 absorbent. Thank you for listening.